So these are the contents of the unit 2 register transfer language, register transfer, bus and memory transfer, arithmetic micro operations. Coming to the first one, register transfer language. In register transfer language is nothing but in order to make a one digital system, we have to interconnect all the digital hardware modules, and we can make a specific information processing tasks. So that is called the digital system. ఒక digital system ద్వారా మనం ఏం చేయొచ్చుమా ఒక టాస్క్ ని ఫాస్ట్ గా కంప్లీట్ చేయొచ్చు. సో డిజిటల్ సిస్టమ్, నార్మల్ సిస్టమ్స్ డిజిటల్ సిస్టమ్ కి డిఫరెన్స్ ఏంటంటే నార్మల్ సిస్టమ్స్ లో మనకి క్లారిటీ అని పర్ఫార్మెన్స్ అనేది చాలా లెస్ గా ఉంటుంది. డిజిటల్ సిస్టమ్ లో ఎఫెక్టివ్ గా ఉంటుంది అనమాట. సో ద డిజిటల్ సిస్టమ్ ఇన్ ద ఇంటర్ కనెక్షన్, యూ హ్యావింగ్ ద డిజిటల్ హార్డ్వేర్ మాడ్యూల్స్ ఆర్ ఇంటర్ కనెక్టెడ్ విత్ ఈచ్ అదర్ in order to perform a information processing task. So that is called the digital system. So in this digital system designs variably uses a modular approach. So in the design system, in this design system, we are using the modular approach. Whatever the approaches we are having, we are using the modular approach. So in this approach, in these modules are constructed from such digital components as registers, decoders. So digitals are the, so what is mean by digital system? Digital system, so in మనం ఏం యూస్ చేస్తాం అంటే మాడ్యులర్ అప్రోచెస్ ని యూస్ చేస్తాం. మాడ్యులర్ అప్రోచెస్ అంటే డిజిటల్ హార్డ్వేర్ మాడ్యూల్స్ అనేది యూస్ చేస్తాం. సో ద వేరియబుల్స్, ద various modules are interconnected. Whatever the modules you are taking, digital hardware modules, those modules are interconnected with a common data and control path to form a digital computer system. So we have going to interconnect all the modules, whatever we are taking, that modules are digital hardware modules, that those are interconnected with each other and with common data and control path to form a digital computer system. Okay, in these digital modules are best defined by the registers, they contain and the operations are performed on the data stored in them. So these operations are executed on data and store the registers is called micro operations. So whatever the operations we are executing, that the data is stored in the registers, so that is called the micro operations. సో డిజిటల్ మాడ్యూల్స్ లో మనకి ఏముంటుందా, రిజిస్టర్స్ ఉంటాయి. సో దే కంటైన్ ఆల్ ద ఆపరేషన్స్. ఆ రిజిస్టర్స్ లో మనకి అన్ని ఆపరేషన్స్ ఉంటాయి. అన్ని ఆపరేషన్స్ మీన్స్ వాట్, అడిషన్, సబ్ట్రాక్షన్, whatever we need in multiplication. So all operations are available in the contained in the registers that perform if you give a specific task. So the task will be performed in the registers. The data will be stored in the registers or called the micro operations. So a micro operations is an elementary operations performed on the information. Micro operations is nothing but it contains the elementary operations that performed on the information that stored in one or more operations. So what they are saying, so in this we are having the micro operation is having is I need to perform some operations that can be performed on the information stored, that can be performed on the information stored. So in this information is having the one or more operations. The result of these operations may be stored in the previous registers or maybe another registers. So whatever the things we are doing, operations we are performing in the digital modules, that operations are stored in the registers, and these registers and in these registers may be stored in the another registers. So the internal hardware organizations of the digital computer is best defined. So the internal hardware organizations of the digital computer law, internal hardware organizations. So in the digital computer, you're having the internal hardware organizations is best defined in specific. So what are the internal organizations? What are the internal hardware organizations in the digital computer? They be having the set of registers. It contains and their functions. It have a set of registers. So manaki hardware lo emunayma, so internal hardware organizations lo, I mean in the digital computer lo internal hardware organization lo manaki konni specific rules anedi define chestunnam. Entante we having the set of registers, it contains and their functions. సో మనకి సెట్ ఆఫ్ రిజిస్టర్స్ ఉంటాయి, దాంట్లో దానికి సంబంధించిన ఫంక్షన్స్ ఉంటాయి. ఇట్ కంటైన్స్ అండ్ their functions. The sequence of the registers It contains and the sequence of the micro operations performed on the binary information stored in the register. So whatever the micro operations we are performing, that can be performed in the binary information. Why we are performing in the digital computer in the binary information? Because the computer understands zeros and ones. So the computer language is a zeros and ones. So the operations is performed in the binary information and stored in the register. Okay, the control, it controls binary registers. It controls initiates the sequence. It controls and initiates the sequence of micro operations. The symbolic notation used to describe the micro operation. The symbolic notations used to describe the micro operations transfers among registers is called the register transfer language. Why we are saying register transfer language? Whatever the information we are taking, that can be denoted in the symbolic notations. We are writing that information in the form of symbolic notations, and it describes the micro operations and transfer among registers. And after that, we are after the representing the operations in a symbolic form, that can be transferred in the register. So then we can say it is a register. So register transfer language loki convert chestam. So whatever the information we are having, that information is converted into symbolic notations, and it can be transferred among the registers. Then we can say it is a register transfer language. The term register transfer implies the availability of hardware logic circuits that perform a stated micro operations and transfers the result of the operation to the same or another register, to the same or another register. So what is the use of register, ma? So register, why we are using register? The register transfer implies, what is mean by register transfer? It implies that whatever the hardware logic circuits are there, that can be perform the stated micro operations, that can be perform the micro operations and transfer the result of the operation at the same and the another registers. So register transfer అంటే ఏంటి మా? మనకి అందులో మనకి హార్డ్వేర్ లాజిక్ సర్క్యూట్స్ ఉంటాయి. అవి ఏం చేస్తాయంటే మనం ఇచ్చిన టాస్క్ ని మైక్రో ఐ మీన్ దే పర్ఫార్మ్ the micro operations. Some operations will be occurred at that I mean in the register transfer. After that, whatever the output or result we are having, that information is stored in the same register or the another register. The word language, what is mean by language? Language, the transfer register means what I told that. What is the meaning of transfer register language? Transfer register register transfer language, the heading. So what is the mean of that register transfer? I only told that. So that will be transfer the data which will be performed in the micro operations, and that result will be stored in the same register or the another register. So that is called the register transfer. So what is mean by language? So the word language is a borrowed from programmers. The word is borrowed from the language అనేది ప్రోగ్రామర్స్ దగ్గర బారో చేసుకున్నారు, అంటే they have taken from there. So and applied this term in the programming language, that can be applied in the ఆ టర్మ్ అనేది మనం ఎక్కడ అప్లై చేస్తాం? ప్రోగ్రామింగ్ లాంగ్వేజ్ లో అప్లై చేస్తాం. వాళ్ళ దగ్గర నుంచి మనము ఆ ప్రోగ్రామర్స్ దగ్గర నుంచి ఆ వర్డ్ ని బారో చేసాము. సో అండ్ ఏ ప్రోగ్రామింగ్ లాంగ్వేజ్ ఈస్ ఏ ప్రొసీజర్ ఫర్ రైటింగ్ ఏ సింబల్. సో వాట్ ఐ టోల్డ్ ఇన్ ద రిజిస్టర్ transfer, whatever the information I am taking, that can be denoted in the symbolic form. So how we are writing, we have according to the language, the word language, we have borrowed that language from the programming language. So that wise we are writing in the symbolic to specify a given computational processor. So symbolic to perform a given computational processor. So okay, so in this register, this is called the register transfer language. సో రిజిస్టర్ ట్రాన్స్ఫర్ లాంగ్వేజ్ అంటే క్లారిటీగా అర్థమైంది కదమ్మా. సో రిజిస్టర్ ట్రాన్స్ఫర్ యొక్క మెయిన్ మీనింగ్ ఏంటంటే, మన రిజిస్టర్ ట్రాన్స్ఫర్ అంటే మనకు దాంట్లో ఇన్ఫర్మేషన్ అనేది ఉంటుంది. ఆ ఇన్ఫర్మేషన్ ని పర్ఫామ్ చేయడానికి సో హార్డ్వేర్ లాజిక్ సర్క్యూట్స్ ఉంటాయి అందులో. సో హార్డ్వేర్ లాజిక్ సర్క్యూట్స్ ద్వారా మనం అవి ఏం పర్ఫామ్ చేస్తాయంటే మైక్రో ఆపరేషన్స్ అనేది పర్ఫామ్ చేస్తాయి. పర్ఫామ్ చేసిన తర్వాత మనకి మైక్రో ఆపరేషన్స్ అంటే సమ్ బేసిక్ ఫంక్షన్స్ ఉంటాయి, ఆపరేషన్స్ ఉంటాయి, లైక్ అడిషన్, సబ్ట్రాక్షన్, లేకపోతే మూవ్ చేయడం, యాడ్ చేయడం, లేకపోతే రిమూవ్ చేయడం, సో డిలీట్ చేయడం. సో దీస్ ఆర్ ద డిఫరెంట్ టైప్స్ ఆఫ్ ఆపరేషన్స్ విల్ బి అవైలబుల్. So after performing that operations, the result will be stored in the same register or the another register. So that is called the meaning of register transfer. లాంగ్వేజ్ ఇస్ నథింగ్ బట్ లాంగ్వేజ్ అనేది ఎక్కడి నుంచి వస్తుంది? లాంగ్వేజ్ విల్ బి బారోడ్ ఫ్రమ్ ది programmers. Nothing but it is a programming language. So in order to perform a symbolic representation, you are borrowed that name from the programming language, and we are performing some specific given computational process. So that is called the register transfer language. Now we are talking about the register transfer. What is mean by register transfer? So the computer register are designated by capital letters. The computer registers, whatever the computer register లో మనము ఏదైతే టైప్ చేస్తాం, ఫర్ ఎగ్జాంపుల్ మూవ్ అనుకోండి, క్యాపిటల్ లెటర్స్ MOV అని ఇస్తాం షార్ట్ కట్ లో. MOV షార్ట్ కట్ లో అయినా ఇవ్వచ్చు, నార్మల్ గా MOV అని ఇవ్వచ్చు. అన్ని అనేది మనము క్యాపిటల్ లెటర్స్ లో డినోట్ చేస్తాం. R1 అని, R2 అని, లేకపోతే L1 అని, లోడ్ LOAD లోడ్, ఇవన్నీ ఏంటంటే మనము మొత్తము క్యాపిటల్ లెటర్స్ లో నోట్ చేస్తాం. కంప్యూటర్ రిజిస్టర్స్ ఆర్ డిసిగ్నేటెడ్ by capital letters to denote the functions of the register. So ఏదైనా ఫంక్షన్ నోట్ చేయాలి, so I have to move the data from A to B. So everything I am denoting in the capital letters. So the computer registers are designated by capital letters to denote the functions of the registers. For example, the register that holds an address of the memory unit is called MAR. So the register are going to hold the address of the memory unit. So that is denoted in MAR, capital MAR. So the individual flip-flops in an n-bit register, are numbered from 0 through n-1. Whatever the register we are taking, that register is denoted from 0 to 0 to n-1. So the register is filled with n0 to n-1, starting from 0 in the rightmost position and increasing the numbers towards the left. Okay, so starting from 0 in the rightmost position and increasing the numbers towards the left. So in this register transfer, we are going to represent how we are using the registers. So this is the diagram. I'm having small diagram. So in this diagram, so this is the main diagram. So in this diagram, I'm having the A register R. So whatever the registers we are designated, the denoting in the capital letters. So R1 I have written here. This is the register A. A is the register. The first box is the rectangular box. That is the register R. So this is one register. In this register, I am taking the bits, individual bits. So here we are in the B diagram. We are having 0 to 7 bits. In the counting from 1 to, you can say it is a 8-bit. Okay, now 8-bit. We are having the individual bits. So this is a C is a numbering of bits. So every register we are in the register, whatever the bits we are taking, for that bits I am providing the numberings. Okay, 0 to 15. So we are providing the sequence numbers. So whatever the values we are taking, we are representing some sequence numbers to that value bits. Okay, so we are representing a common A with the name of register inside. Individual bits B. Numbering of bits in 16 registers are shown in the figure C, and in the top of box that is D, figure D shows the 16-bit register. It is participated into two parts. So in the D, we are having the divided into two parts. Whatever the bits we are taking, that is a 16-bit register. That register is divided into two bits, like 8 bits and 8 bits. That like, okay, and the partitions will be done. The symbolic PC 0 to 7 or PC of the program count. PC means program count. The program count will be start from 0 to 7, and program count assist refers to be low order byte, and PC 18 to 15 or PH high order byte. So 0 to 7 వచ్చి low order byte, 8 to 15 అనేది high order byte. Okay na? So what is mean by register? Diagram D అనేది ఏంటమ్మా, మనం 16-bit రిజిస్టర్ తీసుకుంటాము. 16-bit రిజిస్టర్స్ లో టాప్ ఆఫ్ బాక్స్ అనేది టూ పార్టీషన్స్ లాగా రిజిస్టర్ ని 2 parts లాగా డివైడ్ చేస్తాము. సో దాన్ని మనము ప్రోగ్రామ్ కౌంటింగ్ అనేది ఎలా జరుగుతుందంటే 0 to 7 లాగా జరుగుతుంది. 0 to 7 నుంచి 8 to 15 లాగా, అంటే కౌంటింగ్ వచ్చి 16 bits. సో ఫ్రమ్ ఫస్ట్ నుంచి కౌంట్ చేస్తే 16 bits వస్తాయి. కౌంటింగ్ వచ్చి 0 to 7 8 to 15 తీసుకుంటాము. సో 0 to 7 అనేది దాని ఏమంటారు అంటే లోయర్ ఆర్డర్ బైట్ అంటాము. 8 to 15 అనేది హయ్యర్ ఆర్డర్ బైట్ అంటాం. సో దిస్ ఈస్ ద వర్కింగ్ design of this registers. Okay, so the information transfer from one register to another is designated by symbolic form by means of representing operator is known as register transfer. So whatever the information we are having, that information transfer from one register నుంచి ఇంకో register కి transfer చేస్తాము. అది కూడా in the symbolic form, but that means replacement of operators is known as register transfer. So I'm showing small example. So how we are representing. So this is the information transfer. So in this information transfer, we are having a symbolic form. This like R2 gives rise to R1. This is denoting. It means what? Register, the content of the register R1 is moving, transferring into the R2. So R2 is the storage. It is a storage, and in this storage R2, we are going to store the R1 కంటెంట్. R1 లో ఏముంటాయో వాల్యూస్, ఆ వాల్యూస్ అనేది R2 లో స్టోర్ చేస్తాం. అంటే ఆరో మార్క్ అనేది R2 వైపు చూపిస్తుంది కాబట్టి ఆరో మార్క్ ని డిపెండ్ అయ్యి మనము స్టోరేజ్ అనేది చేస్తాం. ఆరో మార్క్ అనేది దేని మీద చూపిస్తుందో ఆ ఆరో మార్క్ లో దగ్గర ఉన్న R2 అనేది వాల్యూస్ ని స్టోర్ చేసుకుంటుంది. సో వాట్ ఎవర్ ద కంటెంట్ అవైలబుల్ ఇన్ ద రిజిస్టర్ R1, that information is transferred into the register R2. We are moving the data into the R2. So that is the representation of the register transfer. So why we are using register transfer? The information transfers from one register to another register that can be registered in the form of symbolic form by means of a replacement of operator. So this arrow mark is nothing but operator, is known as register transfer. The statement is R2. It denotes a transfer of the content, the register R1 into R2, register R2. The content and offer cannot be changed after transfer. Transfer అయిన తర్వాత ఎలాంటి ఇన్ఫర్మేషన్ అనేది చేంజ్ కాదు. The statement specifies the statement specifies the register transfer implies the circuits are available from the outputs of the source register to input of the destination register, and the destination register has parallel load capacity. We want to transfer to occur only under determined control condition. This can show means this can be shown means statement. So what is mean by specific ఒక statement ని ఎలా రిప్రజెంట్ చేస్తున్నానమ్మా? So the register transfer implies the circuits available from the outputs of the source register to input of the destination register, and that register and destination register has a parallel load capability. Okay, in this we are representing in this we want to transfer to occur only under a predetermined control condition is shown in the if then statement. We are using the if then statement. If we use this is the statement, if p is equal to 1, then p gives rise to R1. So where p is called the control signal. So p అనేది ఎందుకు యూస్ చేస్తున్నామా? p అనేది 1 ఉంటే that p అంటే కంట్రోల్ సిగ్నల్, అండ్ వై వీఆర్ యూజింగ్ p అనేది మనం డేటాని కంట్రోల్ చేయడానికి p అనేది యూజ్ చేస్తున్నాం. ఫర్ కంట్రోలింగ్ దిస్ సెక్షన్ వీఆర్ యూజింగ్ ది p. So if it is sometimes convenient to separate the control variables from register transfer operation by specifying a control functions. So what is the main use of this p? It is used for the controlling the signal between the register and register R2 and R1. So by specifying the control functions, a control function is a Boolean variable that is equal to or 1 or 0. The control function is as follows. What is the control function is as follows? P is to R2 gives rise to R1. Okay, here the control condition is terminated with the colon. So the control అంటే ఏంటి? p అనేది దేంతో టర్మినేట్ అవుతుంది? colon తో టర్మినేట్ అవుతుంది. And after that colon, we are representing the symbolized requirement that transfer the operations by executed by the hardware only if p is equal to 1. p is equal to 1 ఉంటే కండిషన్ మనము ట్రాన్స్ఫర్ చేస్తున్నట్టు. p అనేది కంట్రోల్ p అనేది 1 ఉంటే మనకు p అనేది p is nothing but it is a control signal. It is controlling the data between R2 and R1. So that is why if it is p, if it is only P, the transfer operation is executed by the hardware. Every statement written in a register transfer notation implies a hardware construction for implementing the register. Shows the block diagram. We are having the block diagram in this. So this is the block diagram. In this, we are having the control circuit. So in this control circuit, we are having R2 register and R1 and clock. So in this transfer, in this diagram, we are transferred from R1 to R2 when P is equal to 1. Condition P is equal to 1 ఉంటే మనము transfer చేస్తున్నాము. So the transfer. So every statement written in a register transfer notation, the hardware construction for implementing the register. So this is called the diagram. So then N output, the N outputs of register R1. N outputs we are having. The register is R1 and are connected to the N inputs of the register R2. R1 అనేది ఏంటమా N outputs of the register R1. R1 అనేది N outputs ఉంటాయి. అది దేంతో కనెక్ట్ అయి ఉంది N inputs of the register R2. So it is assumed that control variables P is synchronized with the same clock as one applied by the register. So ఇక్కడ ఏంటంటే మనం కంట్రోల్ అనేది యూస్ చేయాలి. P is equal to 1 అయితే R1 లో ఉన్నది డేటా R2 లోకి స్టోర్ అవుతుంది. Register R1 అనేది outputs of the register R1. It is the inputs of the register R1. So this is connected to the R1 to R2. Okay, this is the clock rate. So this is the clock and this is the load. Okay, so in this timing diagram, P is activated in control section by rising edge of the clock pulse at the time T. The next positive transition of the clock at time T plus 1 finds the load input at Q and the data inputs and data R2 are then loaded into the register in parallel. So if the condition P is equal to 1, so the clock pulses will be rises up and down, and the clock pulses are at the T, and the next positive transition is the clock time T plus 1. It finds the load input active and low and data inputs of the R2 are loaded into the registers. సో ఎప్పుడైతే పల్సెస్ అప్ అండ్ డౌన్ వెళ్తున్నాయంటే మనకు డేటా అనేది లోడ్ అయినట్టు. ఓకేనా, ట్రాన్స్ఫర్ రిజిస్టర్ అనేది ప్యారలల్ గా లోడ్ అవుతా ఉన్నట్టు ప్యారలల్ గా. ఓకే, సో ద బేసిక్ సింబల్స్ ఆఫ్ ది రిజిస్టర్ transfer notation is listed here. So in this we are having the P may be go back. P may be go back to 0 at the time T plus 1. Otherwise the transfer will occur with every clock pulse transition while P remains active. Note that the clock is not included as a variable in the register transfer statements. It is assumed that all the registers occur during a clock edge transition. So this is if the condition may be a 0, this occurrence will be occurred. So the arrow denotes whatever the arrow we are using between the registers that will transfer the information and the direction of transfer the information between the register. If the direction of the transfer, so the arrow mark will be showing which arrow mark అనేది ఏ రిజిస్టర్ మీద ద్వారా అయితే చూపిస్తుందో దాంట్లో మనం స్టోర్ చేస్తున్నట్టు. ఓకేనా, సో ద ఆరో డినోట్స్ ద ట్రాన్స్ఫర్ ఆఫ్ ఇన్ఫర్మేషన్ అండ్ డైరెక్షన్ ఆఫ్ ట్రాన్స్ఫర్. ఏ కామా ఈజ్ యూజ్డ్. కామా అనేది యూజ్ చేస్తున్నాము. కామా ఏంటంటే 2 ఆపరేషన్స్ ని సపరేట్ చేయడానికి. సో ఇప్పుడు ఇక్కడ కింద చూసుకుంటే స్టేట్మెంట్ T కోలన్ R2 గివ్స్ R2 ఆరో R1 తీసుకున్నాను, కామా పెట్టాను. ఎందుకంటే ఇక్కడ 2 స్టేట్మెంట్స్ ఉన్నాయి. 2 స్టేట్మెంట్స్ కి డివైడ్ చేయడానికి కామా యూజ్ చేస్తాం. ఓకేనా, ఎగ్జిక్యూటెడ్ అట్ ద సేమ్ టైం. ఆ 2 స్టేట్మెంట్స్ అనేది కామా యూజ్ చేసి ఒకేసారి ఎగ్జిక్యూట్ అవుతాయి. ఇట్ denotes the operation. So the statement R2 arrow R1 arrow R2 denotes the operation exchange the content of the 2 registers during 1 clock pulses, provided that T is equal to 1. The simultaneous operations is possible with registers that have edge triggered flip-flops. Okay, so we having in this flip-flop. This is the table mark. So in this table it will be denoting here. So register transfer symbolic basic symbols. So letters, we are denoting the data in the form of letters or numerals. So denoting in the register that is capital letters, that is MAR to dislike, and parenthesis also we are using in the registers denoting with the part of the register. So R2 of R minus 1, R minus 7, dislike. Okay, and arrow mark is denoting in order to transfer the information from one register to another register, and comma is used to separating the two operations. So these are the different things we are going to use in the register transfer. Next, coming to bus and memory transfer. What is mean by bus and memory transfer? A typical digital computer has many registers. So a digital computer lo manaki so many registers untai and paths. So many registers and paths must be provide the transfer information from one register to another. A bus structure. Bus means what? Whatever the devices we are having, the devices is connected. This is the bus structure. Okay, this is the bus system. So the registers are connected in the bus. Okay, that consists of set of common lines for each bit of a register through which binary information is transformed one at a time. Control signals determine which register is selected by the during each particular register transfer. So we having one way of constructing a common bus system with a multiplexer. The multiplexer selects the source register whose binary information is then placed on the bus. The construction of the bus system for 4 register is placed on the bus, and each register has 4 bits numbered with a 0 3. The bus consists of 4 into 1 multiplexers. So this is the 4 into 1 multiplexer. This is the multiplexers. These are connected in the bus having the 4 data units. So these are the 4 data units. So D1, D2, this like data units. We are having 4 data units. Okay, and through 0 through 3 and selection inputs and 2 selection inputs we are having. So this is the 2 selection inputs. So where we having S1 and S2 is the S0 and S1 is the 2 selection inputs. So in order to complicate the diagram, 16 lines crossing each other, we are using the labels connections from outputs of the registers to the inputs of the multiplexer. For example, output 1 register A is connected to the input 0 of multiplex 1 because this input is labeled A1. The diagram in this diagram, the bits in the same significant position, each registers are connected to the data inputs of the one multiplexer to form a line of the bus. So this is the diagram. In this diagram, we are having 4 into 1 multiplexer, 4 multiplexers and 4 data units. So this is the 4 data register 1 data units, and we are having the selections S0 and S1. So these are the 16 lines we are connected with each. Okay, so this is the structure of the bus, and in this structure, for example, output 1 or register output 1 register A. Yeah, register A is the end of the end register అమ్మా పక్కన లాస్ట్ ఉంది కదా రిజిస్టర్ ఏ అని కనిపిస్తుంది. సో రిజిస్టర్ ఏ అనేది దేనికి కనెక్ట్ ఉంది? ఇన్పుట్ 0 ఆఫ్ మల్టీప్లెక్సర్ 1 కి కనెక్ట్ అయింది. ఇన్పుట్ 0 మల్టీప్లెక్సర్ 1 కి కనెక్ట్ అయింది బికాస్ దిస్ ఇన్పుట్ ఈస్ లేబుల్డ్ యాజ్ A1. సో ది thus multiplexer 0 multiplexers MUX 0 multiplexers, the 4 0 bits of the registers are so on. The 2 selections lines S1 and S0 are connected to the selection inputs. Inputs of the 4 multiplexers. The selection lines chooses 4 bits of one register and transfer them into 4 lines common bus. So when S1 S0 is equal to 0 0, the 0 data inputs of all the 4 multiplexers are selected and applied to the outputs and that form. The bus is the causes bus lines that receives the content of the register A. Since the output of these registers are connected to 0, the data inputs of the multiplexer. Similarly, register B is selected, S1 S0 is equal to 0 1 and so on. So in this below we are having this is the table function, bus of the table function. In this we are having S1 and S0. 0 0 will select A, 0 1 will select B, 1 0 will select C, 1 1 D. This like we are selecting the sections. Next, in this in general, we are having the bus system will be multiplexer K registers of n bits. each to produce an n-line common bus. The number of multiplexer needed to construct the bus is equal to n. So the number of bits in each registers, the size of each multiplexers must be k into 1 since it multiplexers k data lines. The transfer of information from a bus into one of many destination registers can be accomplished by connecting the bus lines to the inputs of all the destination registers and activating the load control of the particular destination registers. Okay, when the bus is includes the statements, the register transfer the symbolized form. Bus gives rise to, I mean, bus implies C1, this implies C1, and R implies C. Okay, so this is the representation. The content is transferring from bus and into loading into the register R1. Okay, na register R1. Okay, so this is the main working of the bus. In the bus we are having three state bus buffers. Three state bus buffers and in and in this three state bus buffers we are having the diagram. So in the this is will be take more time. So up to here, up to bus, I'm going to stop the class. So thank you for listening this class, ma.